So we want to okay, the audio. Yeah. The trip away and microphone. Yeah, that's good, correct? That's good. Okay. Okay. So, guys, let's begin. Again, sorry for the delay, guys. You see, morning client calls. Sometimes they ask you to work on weekends as well. Okay, fine. So, we'll begin from where we left yesterday, and that is the strings, right? Yeah. We were done with type casting and conversion. Strings, how much we had covered. Okay, type casting and conversion. I got it done. String, the uppercase, lowercase, the title case, and strip we are done, right? Strip and strip we are done. Okay. Okay, perfect. Now let's begin with the topic for today. I mean, the remaining topic, and then we can move on to the topic for today, right? So, strings in Python. Search and replace method. Until yesterday, what we had seen is what a string is and how a string is stored in Python. And basically, I mean, I told you that we have strings that are stored index by index, right? Every character has its own index, correct? Now you can index a string in Python using a square bracket. Then we looked at the case conversion, the uppercase, lowercase, capitalize, and title. We've looked at strip, the method strip, lstrip, and rstrip, right? If you remember, this basically strips off any empty spaces in the string, lagging or leading empty spaces in the string. Now, the next is find index and replace. Okay, find index and replace. Now, find returns the lowest index of a substring. So basically, if there's a string, suppose, let's say that. Now, let us say that if there is a string, let's call the string as, again, I'll take the same thing. Hello world, right? Followed by exclamation, right? Now, suppose you need to find at what index the substring. I mean, see, this is one entire string. This is called an entire string, and a part of an entire string like hello or even a small h, right? It's called a substring, right? Now, if you want to check in a string whether any substring is present. Let's say that I need to check in this hello world if world is present, right? So for that we use the function of find, right? We use the function of find. Find returns us the index where it encounters the substring, Okay, so let's create a string in Python. Let's create this sentence. So I'll create this sentence in Python. And what are they trying to find out? Let's check. So they are trying to find out, is the substring is it present in this sentence, in this string, right? Is the substring is present in this string, right? So what is the syntax? Index is equal to sentence.find. Sentence.find. So let's do this thing, right? And d is equal to, this is the string that we have, sentence dot find, and let's find is. Let's try to find is. Execute this. Okay. Execute this. This is going to return you. Okay. Print index. Yeah. Now this is going to return you the index at which the substring was encountered. Okay. So let's check. It's returning 7. Let's see if at all it is actually 7. 0, 1, 2, 3, 4, 5, 6, and then 7th. So basically this substring was found at index number 7. This substring was found at index number 7. Now let us check one more thing. Let us check one more thing. Is not present in the string. Is the substring not present in the string? Okay. So execute this. You'll find -1. Now this -1 suggests that the string is not present in the substring is not present in the string, right? So by default, when you try to find any substring, it is going to give you the occurrence of the first substring, and if it is not present, if the substring is not present, it will by default give you a -1. Right? It will by default give you a -1. Next is replaced. Now the index works in the same way, right? It returns you the index of occurrence of this substring. Replace is a method. Replace is a method where we can replace any substring. Now let us say that over here I want to replace hello by hi. I want to replace this word hello by hi, right? So to replace any substring in the main string, we use the method of replace, right? The syntax, sentence dot replace. First substring is what needs to be replaced, and second substring is the by what the replacement should be done, right? So we need to replace this Python by JavaScript, right? So the first is what is to be replaced, and the second one is by what it needs to be replaced. As simple as that, right? So let's try doing this. Okay, we'll do it in this. Okay. Now, let's say replaced string is equal to sentence dot replace. Now, what needs to be replaced, right? What needs to be replaced is Python, and by what it needs to be replaced? It needs to be replaced by Java. Let's write with Java, okay? And then print the replace string. Print the replace string. Execute this. So see, Java is easy and Java is fun. Okay. Now let us try doing one more thing. Let us try. Let us try changing the case of Python. Okay. Let us try changing the case of Python. Execute this. It is not replaced. Why? Can anyone tell me why this statement, why Python in the statement is not replaced? Right? Even if wrong, it's perfect.
Case sensitive.
Sorry, exactly, correct. If you see Python that I've written is capital. It's case sensitive. Python is a case sensitive language. Here I've written capital Python, and in this string we are not able to see any capital Python. Right? That is why it's not replaced. As simple as that. Right? So again, this proves that Python is a case sensitive language. Okay. Now, next is counting method. Now suppose, let us say that you want to count the occurrence of any substring, right? You want to count occurrence of any substring, right? So let's say our substring is hello all, how are you all doing? Now here, if I want to count, let's say I want to count how many times the substring all is present. How many times it's present? One, two. It's present two times. So basically, in this main string, if you want to count occurrence of any of the substring, any of the smaller string, you use the method count. You use the method count. Okay. The syntax: sentence string dot count, and in the parentheses you need to pass whatever whatever substring for which you need to get the count. Okay. So let us find the count of is, right? Let us find the count of, let's say, let us find the count of Python, right? So sentence dot count, let's say we need to count Python. We need to count Python. So see, Python is occurring twice. Python is occurring twice. Now let us try to find out to count anything which is not present at all. So sentence dot count not substring is not present, it will return you a count of 0. If it's present, it's going to return you some count. If it's not present, it's going to return you 0. Okay, perfect. Yeah, yeah, sure, sure. So this is how these methods work, right? I mean, guys, let me tell you, let me be frank, there are a lot of methods in Python when it comes to string, but I mean, all those cannot be kind of taken within a short span, because you see, this is just a tip of the iceberg, right? So I mean, once you get into exploration, you'll be able to explore more and more methods, right? Now, next is there are these methods, starts with, ends with. These are fairly straightforward method, right? And the name of these methods, the name of these methods, or you can basically call them as functions as of now, right? Every one of these functions have been written for some specific purpose, right? For example, like count is written in such a way that it returns the count of the substring. Okay. Now, starts with, if you see starts with, the name, as the name suggests, it is going to check if the string starts with a specified prefix or a substring. Okay. Ends with, checks if the string ends with a specified suffix. Correct. is alpha is alpha checks if all the characters are alphabetic. Correct. Is digit checks if all the characters in a string are digits. Correct. And is alnum checks if the characters in the string are alphanumeric. Alphanumeric means alphabets and numbers, right? So Let's okay, we'll take some different text, right? Now let's employ these functions to understand. So let's say text1 txt1 is equal to hello, let's say, right? Now hello, okay, fine. For starts with and ends with, will basically use the same. Text one is hello world. Now print text one dot starts with, let's say we need to find if it starts with hello. Execute. Oh, sorry, STARTS. Yeah. Starts with hello. Perfect. It's returning true. Correct? It's returning true. Now, let's say, let's check if it ends with world. If it ends with world, right? So text one dot ends with world. World. It's returning false. Why is it returning false? Can anyone tell me? Why is this returning false to me? I mean, if you read the text, it is ending with world, right? But why is it returning false to me? Exclamation mark. Exactly. Because there's an exclamation mark after word, right? Every single character in Python counts, right? Now it's returning true. Okay. Then let us check if the string is, what was the third method? Yeah, is alpha, right? So print text1 dot is alpha. This is going to check if all the characters in the string are alphabetic or not. False, it's returned false. Why it returned false? Because you are able to see special characters which are present, right? Special characters are present, right? And that is the chief reason why we are able to see false over here, correct? Now, let's say that okay, is digit and is alnum. So let's change the text now. Text2 is equal to hello 111, right? Let's say hello 111, correct? Now I want to check if a text2 consists of alphanumeric values, right? So print text2 dot is alnum. Alnum stands for alphanumeric. It's going to check if all the characters either are alphabets or numbers. So see, true. It's returning true. Why? Because there are alphabets, there are numbers as well, right? So alnum is returning true. Correct. Now let's take one more text. Text3 is equal to, let's say, 100. Text3 is equal to 100. Okay. Now I want to check if the text, if all the characters in the text are numbers or not. Correct. So print text3 dot is digit. True. Why true? Because in our text tree, all the characters are digits, right? Even if you put one alphabet, even if you put one single alphabet, it's going to return false. Correct? So this is some sanity check that we do with the data, right? This is some sanity check that we do with the uh, you can call it with the text data. Okay. So these are some methods that help us, right? These are some methods that basically help us work with the text. Okay. And believe me, guys, all these methods are some or the other were used while writing an algorithm for the chat GPT, right? While writing an algorithm for the chat GPT to do the sanity checks in the data, to understand the data, to basically convert the data into a cleaner format. These are some of the methods that are explicitly used. Okay. Now, the next is split and join, right? Split and join. Now, split is a function, or split is a method that splits your text. Let's say I'll show you. Now, suppose I take the same string, hello world. Now, let's say that you want to split your text into two different words. There are two different words, right? There are two different words in the string. You don't want these two different words to be together, right? You want to split these two different words and store them as separate entities. For that, we have the split method. What it does is it splits the text on the empty space. It splits the text on the empty space, and it creates a list wherein the elements of the list are going to be two words. So hello, the first element will be over here. World, second element will be over here, right? So this is what split method is going to do, right? This is what split method is going to do. By default, it splits in on the white space. Okay. So let's take this itself. Sentence. Okay, we already have sentence, right? So let's say sentence dot split CNTENC, right? Let's print it. Sentence dot split. See, Python first word is easy and Python is fun. So basically, on all the white spaces, when I say white spaces, I mean the blanks between these two words, right? On all the white spaces, this thing has been split, right? The sentence has been split. Now suppose, let us say that you need to split it on some substring, right? You need to split it on some substring. Let's say you need to split it on and, right? So here you will have to pass the substring on which you need to split. You need to get the split done. So see, it's split on and. Python is easy, that is one substring. Python is fun. Correct? Are you able to understand this, guys? The online guys? Any doubts, any questions? Fine. Now, then we have the join method, right? We have the join method. Okay. So join basically is going to, now suppose let us say that this is this is what I will, this is the split that I've done. Now let's say that I want to join the substrings for, or the strings in this list together with each other exactly like this again, right? I want to rejoin, right? So using split, I split this sentence into words, and using join, I'm going to join these words to the original string. Okay, so I'll copy this because again it will take some time. Yeah. Now words words is equal to sentence dot split. Now the string we create, okay, join sentence. They are saying, okay, so join sentence is equal to, let's join them on empty spaces, right? Let's join them on empty spaces. Join dot join. You need to pass the name of the list that you need to join, right? So print join, and let's print the words as well, right? So that you'll be able to understand. Now see, execute this. What did the first method do? First method split the words. First method split the words on empty spaces and created a list. And the second method join, it took the words from the list and joined them with empty spaces. Now let us say, rather than empty spaces, I want to join them on underscore. So what I will do, I will just replace this empty space with underscore. Execute this. See, it's joined on underscores. Let's say I want to join them on hyphen. I want to join them on hyphen, right? Execute this. It will be joined on hyphens. Right, guys? Now, okay, so formatting, format, map, okay, fine. So here, formatting string, there, okay, fine. Now, there is one way in which you can dynamically print the output. You can dynamically print the output, right? It is done using the format method. Using the format method. I'll tell you how, okay? Now, let us say name is equal to John. Okay, let's take the same. Age is equal to 25, right? Now let's say you need to print a statement where my name is John and I am 25 years old. Now see guys, see. Now this is printing, this is called static printing. Okay, this is called static printing. Now if I change the name from John to Johnny, right? If I change the name from John to Johnny, and if I try to print, it's again going to print my name is John and I'm 25 years old. Although now I've changed the name to Johnny, correct? This is what is called static printing. Okay. Now I want to print it dynamically. Dynamically means if I change this name, the change should be reflected over here in this statement. If I change the age, the change should be reflected over here, right? So basically this name and this age should change accordingly when I change the name or age over here, correct? Now this is what we call dynamically printing. So this can be achieved using the format method. How? This syntax is uh, I mean, you can say by default, right? This syntax is by default. By default, you will use curly brackets in places wherever you require the dynamic printing, right? So I instead of name I want dynamic printing. Instead of age I want dynamic printing. So basically when I change the name it should reflect over here. When I change the age it should reflect over here, right? Now here you have created two dynamic printing, two curly brackets that specify dynamic printing. After that you will have to give the format method, and for the first gap, understand this, for the first gap or for the first dynamic printing you should specify this variable name name, okay? And then for the second dynamic printing, for the second gap, second fill in the blank, you should you should basically put this second variable, correct? Now try printing it out. Now try printing it out. See, my name is Johnny and I'm 25 years old. Now let me change the age to 30 years. Let me change the age to 30 years. See, my name is Johnny and I'm 30 years old. Now let's do one thing. Let us reverse this name and age. Let us reverse this name and age. What happens? The first gap will be filled by the age and second gap will be filled by the name. Correct? So the order of these variables in the format in the format method, the order of these variables should be in accordance to the gaps that you have, right? The first is going to fill the first gap, second is going to fill the second gap. Okay, so this is how you can dynamically print in Python. This is how you can dynamically print in Python. And format map, it's similar to format, right? Then we are already done with the type conversion, typecasting and conversion and the operators yesterday, right? So, I mean, this saving is not required, it's already saved. See, in Google Colab, all changes are already saved, right? It's as you write the code, it saves on the go, right? But still, you can just do a save, and we are good with our first notebook, right? The introduction to Python. Now, coming to today's topic, actually today's topic ideally should have been functions, loop functions, and error handling. But until and unless you don't understand the multiple data types, you will not be able to work with loops, right? Loops basically needs you to understand the multiple data types that you have in Python, which are list, tuple, set, and dictionary. Okay, so that is why I have swapped this session. Today I will be taking data structures, list, and tuple. The next session we will be taking data structure, dictionaries, and set. And then once we are done with these multiple data types, the subsequent session will be loops and error handlers. Okay, so I've just wiped the sessions, right? Don't worry, this topic will be covered in the fourth session. Okay, this loop functions and error handling will be covered in fourth session. First, today and the next session, we will cover the multiple data types, right? And the methods associated with it. Okay, fine. So, today what we are going to have a look at is data structure, overview of list and tuples, creation of list, basic operations on list manipulation techniques, slicing and indexing of list comprehension. I'll see if, okay, just let me see if list comprehensions consist of functions. If list comprehension consists of functions, then we can take it out. Okay, list comprehension consists of loops. Okay, fine. We can take it out. Right? List comprehension I'll take once the loops are done. Okay. Then creation of tuples, basic operation on tuples, slicing and indexing of tuples, and common operations on both list and tuples. Okay. So today we are going to learn the multiple data types in Python. Right? We are going to learn the multiple data types in Python. Okay. Now, so as of now, guys, I mean, apart from string, we've been able to see single data types in Python. Okay, like number, right? Number is a single data type. A number or a float or a complex, anything, right? These are single data types in Python. Okay, strings, you can say that they are multiple because if you see, a string consists of multiple characters. A string consists of multiple characters. That is why you can say that, okay, strings can be called as a multiple data type, right? But when it comes to numerical values, these are singular data types, right? So I mean, if I write 1 2 3, 1 is a different character, 2 is a different character, 3 is a different character, this does not make sense. 1 2 3 is 123. That's a simple number, correct? It's not like HELLO, H is different, E is different, L is different, L is different, O is different, correct? So here, if you try, okay, I'll show you. Okay, now I'll show you the difference. str is equal, str1 is equal to, let us say, hello. Now, if I try to index the first letter or the first character of string 1, str1, it will be str1 followed by square bracket, and what should I put for the first character? 0. Perfect, right? So str1 0, it returns me h. It returns me h. This is going to be returned over here, right? But now if I try, but now if I try the same thing with a number, num is equal to 1 2 3. Let's try doing num 0. Now I'm trying to index the first digit over here. Execute, it returns you an error, right? Int object is not subscriptable. This means that you cannot, subscriptable means indexable, right? Subscriptable means indexable. A string is indexable because string is collection of multiple characters, but here it's not a collection of multiple characters. This is plainly a number. This is 123. You cannot separate one. You cannot index one over here. You cannot index two. You cannot index three, right? As simple as that. This is a single entity, right? So when it comes to numbers, we've been seeing single data types, right? We've been seeing single data types. Today we are going to see at the multiple data types in Python, right? The most basic one and the most extensively used one of them is a list. Right? Now, a list is a data type. List is a data type which can store multiple values in itself. Right? How does a list look? List begins with a square bracket, ends with a square bracket, and has comma separated values in it. Right? List begins with a square bracket, ends with a square bracket, and has comma separated values in it. Right? So list, this element is different, this element is different, this, 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 this. All these 7 elements individually are different. Okay? This is what a multiple data type basically is. Now, the next question, that you should have, sorry, yeah. The next question that you should have is whether a list can only contain of numeric values only. Whether a list can contain numeric values only. It is not mandatory at all. A list can contain an integer, it can contain a float, it can contain a string, it can contain a date, uh, 1204, right? It can contain a date, right? It can contain a complex. A list can contain any what you call any data type. A list can contain any data type, be it a number, be it an integer, be it a decimal, be it a string, be it a date, be it a complex number. Everything is allowed. Even a boolean. Every single data type is allowed in a list. Correct? And and above that, a list can contain a list inside itself. List inside a list. Okay, so like we have this bigger list, a small list 1 2 3, then second small list 4 5 6, then next small list 7 8 9. So this is a bigger list which contain smaller list inside it, right? And this concept is called nested list, right? This concept is called nested list. We are going to look at this as well. Okay, so there are few characters of a list, very important characters. If you go for a basic Python interview, then these characteristics, uh, I mean, you can 90% of the time you can expect a question on these characteristics, right? Okay, so data structure is way of, okay, importance of data structure, efficient data organization, algorithm efficiency, code reusability. This code reusability is basically the concept of loop that we are going to see. Scalability, critical for handling larger data set in application as applications grow, and abstraction and organization. Right. So it's basically more of organization of the data. Right. These multiple data types that we have, it's good for organized to hold the organized data. Right. Data structure, organizing, storing data. These are the important ones that we extensively use. List, tuple, set, dictionaries. These are the ones that are extensively used in Python, right? Then arrays is a part and parcel of a library in Python that is called NumPy. And arrays arrays come into play when you feed the data into machine learning algorithm, right? Arrays come into play when you feed the data into machine learning algorithm. Okay, so it's again an important concept. Arrays generally for machine learning algorithms, right? Then linked list. If you have data which is kind of populated, I mean heavily populated data, you can distribute the data into smaller lists and then link them together. So basically, linked list concept is, now suppose you have 1, 2, 3, 4, 5, 6. Right now, I've just segregated the data. I mean, I've kind of split the data. Right. This was 1, 2, 3, 4, 5, 6 was one big list. Right. The data was too much for a single list to handle. So what did I do? I just split the data into two different lists. Right. To unburden this single list. Now I will link these two lists in such a manner that the last element of the first list and the first element of the second list will be connected to each other, right? Will be connected. So 3 will be pointing towards 4 and 4 will be pointing towards 3. This is the concept of linked list. But this is only true when you have one single list which is burdened a lot, right? One single list which is handling big data. Okay. Then stacks and queues, and then trees and graph. Trees and graph is basically hierarchical data, right? I mean, you have some hierarchical data, right? Like you have the CEO of the company, then you have the presidents of the company, then under the presidents you have the vice presidents of a company. Under them you have the manager, senior managers and employees, right? So this is the hierarchy of an organization. And if you store a data in hierarchical format, it goes under the trees and graphs. Okay. Now, so in the in today's session and the subsequent session, we are going to cover these four topics, right? List, tuples, sets, and dictionary. Okay. Overview of list and tuple. Now see, lists are ordered. One important characteristic: ordered means they, every single element, just like string that we saw the other day, every single element will have an index, value associated, right? And they will be in order, right? This element index 0, this element index 1, index 2, index 3, index 4, index 1, right? And anytime or every time you print this list, it is going to be printed in this same order, unless and until you modify the list. Okay, it's going to be printed in the same order, right? That is why we call list as an order. Second most important characteristic of a list is it is mutable. Mutable. Dictionary meaning of mutable is changeable. Changeable, right? So basically, if rather than 3, I want to change this number or this element to 30, I will be able to do it. It's possible. With list, it is possible, right? So they are changeable. You can make modifications. You can change the existing list, right? Mutability. Mutable means you can modify, add, remove elements after creation. So once you create a list, I don't want this number, I can remove it. Let's say I, instead of 7, I need to add 8, I can add it. I need to change number 3 to 30, I can modify, I can change it, right? So this comes under the heading of mutability. Very important concept, right? I mean, interviewers generally the interviewers they wait for this word to come out of your mouth, right? Because because they expect you to know the most important property of a list: mutability, right? Mutability. Syntax: to create a list, you have to create it using a square bracket. Correct? Now let me take you to the properties of tuples. Tuples, again ordered, but the biggest difference between the two: mutable, immutable. Tuple can be created using parentheses, just like list. It can be created using parentheses, comma separator value. But if I want to remove this element, once now I've created the tuple, if I want to remove this element, not possible. If I want to add any new element, not possible. If I want to change this 3 to 30, not possible. Tuples have a strict data integrity. You cannot change. Once you create a tuple, you cannot change it at all. This is the property of immutability in tuples. Biggest difference between list and tuples: list mutable, you can modify, change it at any point of time. Tuples immutable, once you create them, you cannot change them. Now see the example of list: 1 2, then we have a string, then we have 4.0. Correct? You can index it using this, right? We'll see that. We have it somewhere ahead. Indexing, creation, basic operation. I think we have indexing, manipulation, slicing. Yeah. Okay. So yeah. Overview of list and tuples. Key differences: list use square bracket to be declared. Tuples use parentheses. Okay. One difference. But this is not the main one. This is not the main one. This is just how you create it. As simple as that. This is the main. Lists are mutable, tuples are immutable. List can be changed, modified, add elements, remove elements, possible. Tuples, not possible. Due to immutability, tuples generally have slightly less overhead than list and can be more efficient in certain situations. Certain situation means if you want to create if you create some data which you don't want to change while writing the code, even by mistake, you don't want that data to be changed at all. There you use tuples. In that case, you use tuples. Okay, because once you try to change, it's just going to fail. The program is going to return you error. Lists are suitable in situations where element may need to be added, removed, or modified. Tuples are preferred for the situation where immutability is desired. Even by mistake, let's say that you declare a tuple over here, you write a 200 line code over here, and by mistake you try to modify this tuple, it is going to return you error at that point of time. The program will not execute. It will execute until here, and it's going to stop, right? It's not possible. So if you don't want the data to be changed even by mistake, then you use the concept of tuples. As simple as that. Okay, so now let's begin writing the code for list and tuples. Okay, so let me name list and tuples. Let me name first list and tuples. Okay. So the first thing is creation of the list. Creation of the list. You can create an empty list using a square bracket with nothing inside it. Okay, with nothing inside it. So let's create empty is equal to square bracket, and let's check the type of this variable called empty. Now guys, we have used, if you see over here, we are using the assignment operator is equal to. So empty is a new variable that I've created, and I'm assigning an empty list to it, right? Let's check the type of empty. Type is a list. Okay. Then let's say we create our first list, list1, right? Now guys, list, it's a class or an object in Python. Don't use a variable by that name. Okay, don't use a variable by that name, because I mean, if you see this, this font itself has changed. So this, you should be able to understand that this is a keyword, or rather you can say it's a class in Python, right? So take some other name, list1, list2, it's perfectly fine. Don't use list. Okay, it will get Python also confused, it will get you confused, right? Both of you will be confused. So list1 is equal to, let's say, 1 comma, sorry, comma 2 comma 3 comma 4 comma 5 comma 6, 4 comma 5 comma 6, right? Let's check the type of the list over here. Let's check the type of the list over here. Again, it's a list. The data type itself is a list, right? In Python, the data type itself is a list. Just like integer, float, string, list is an explicit data type in Python. Okay. Now you can also create a list2, let's say, is equal to, I can create a list with 1, 2.5, let's say 3, correct? Then true. So I've used an integer, I've used a float, I've used a string, I've used a boolean. Let's say if I'm able to create a list, print type of list 2. Execute. Yes, we are able to create a list with multiple data types. With multiple data types. Correct? So this is how we create a list. This is how we create a list. As simple as that, straightforward. Now, so syntax for creating lists, yeah, flexibility of data types. A list in Python can hold elements of different data types. Now I can even create a list which consists of list itself, right? So let's call it nested is equal to a list. Inside that I create a list 1 comma 2 comma 3 comma, second list 4 comma 5 comma 6, third list 7 comma 8 comma 5. Okay, and let's check the type of this as well. Type list nest video. Again, that's a list, right? So this concept is called a nested list, right? A list inside a list, and it's perfectly allowed. It's perfectly allowed. Okay. Now, basic operations on list. Basic operations. So exactly like in the string, we have seen these functions, right? We have seen some functions to manipulate a string. If you are able to see over here, if you remember, yeah. So like we have text dot upper, right? This function did what? This converted into uppercase. Text dot lower, then capitalized title, right? Exactly in the same way, we have functions that work with list as well, right? So we are going to have a look at these functions. We are going to have a look at these functions. Okay. Now, the first one is append. The first one is append. Let's create a list, guys. Let's create a list. List1 is equal to 1, comma 2, comma 3, comma 4, comma 5, comma 6. Right? Now, let's use the first method called append. List1 dot append, let's say 7. Have a look at the output. Have a look at the output and let me know what do you think is happening over here. Oh, it's going to be a non type. So, let's dot append 7 print list one. Tell me what has happened over here. Exactly. The append functionality, what it does is it is going to add this element at the end of this list. At the end of this list. Okay. Now, let's say I create list2 is equal to again 1, comma 2, comma 3, comma 4, comma 5, comma 6. List2 dot append. Let me now try to append 7 comma 8. 7 comma 8, right? Print list2, print list2. Can you tell me what has happened with the list2? Look at the output and can you tell me what has happened to the list2? 7 8 has appended, but if you see, while appending, this 7 8 has been appended as a list. So basically, while appending, it has considered this as a single entity, one single entity, right? This small list that I've passed of two digits has been considered as a single entity, and the entire list has been put as an element over here, right? Now, so this is the append method. This is the append method, right? Now, okay. Now, I would like to, okay. Now, I would like to, let's do the same thing. Let's do the same thing, guys. I'm doing nothing different over here, right? I'm doing nothing different. List2 is equal to this. List2 dot, instead of append, I will write extend. Instead of append, I will write extend. Now check what has happened and let me know. Now check the output and let me know what has happened. What is the difference between append and extend? Can anyone tell me what is the difference between append and extend?
It had removed that single entity 7 and 8 from that.
Exactly, exactly. Now what it's done? See, I'll tell you. What append does is 1, 2, 3, 4, 5, 6, followed by a single entity 7, 8. What extend does? 1, 2, 3, 4, 5, 6. Now, instead of adding or sorry, instead of appending a list directly, it is going to consider the elements of the list separately, right? 7 and 8. So after 6, it is going to first add first element of the small list, and then it will add second element of the small list. So it's going to add element by element. This is the major difference between append and extend. Again, one of the favorite questions of the interviewer in Python. What is the difference between append and extend? They will not ask you to write the code for this. They just want the difference. Next is insert. Next is insert. Now suppose we have seen what append does. Append adds at the end. What does extend do? Extend adds at the end. What if you want to add somewhere in between? That makes sense, right? What if you want to add somewhere in between, you use the concept of insert. You use the concept of insert. Now let's say list 2 is equal to 1 comma 2 comma 3 comma 4 comma 5 comma 6, right? Now let's say at index 0 1 2, at this index I want to add a number, let's say 30. I want to add a number 30 at this index in place of 3. So this is index 0 1 2. Let's insert ist2 dot insert. The syntax is first you write the index where you need to insert, second index, and then the value that you need to insert, 30. So basically in list 2, if I convert this statement to English, in list 2, insert a value 30 at index number 2, right? Then do print list 2, do print list 2. So see, now instead 3 has been pushed back, right? 3 has been pushed back. Instead of 3, the third element is 30. So you can very well insert any value at any location in a list, right? And this is the modification that I was talking about, right? This is the modification, this is the mutability property of list. You can add elements, you can insert elements, right? We'll see how we can replace, how we can change anything. Got it, guys? Basic operations. Yeah. Now, you can go ahead with a removal of the elements as well. Like you appended means what? Adding new elements. You can very well go ahead and remove the elements as well from a list, right? There are three methods. Either you use remove, second you use pop, third you use delete. Del is a keyword that says delete. Okay. Remove, it's going to remove based on the value. Pop is going to remove based on the index, right? And delete, again, it's going to delete based on the index. Okay. So let's create a list. 1 is equal to 1, 2, 3, 4, 5, right? List 1 dot remove. List 1 dot remove. Let's say I want to remove 4. Print list 1. Print list 1. So see, value 4 has been removed. Remove uses the value, guys. Remove this method uses the value for the element to be removed. Okay. Let's do the same thing with another method called pop. Let's do the same thing with another method called pop. List 1 dot pop. I want to remove in the value at second index, let's say 0, 1, 2, second index. This is the second index, right? I'll pass the index value over here. As simple as that. List 1 dot pop 2. See, element 3 has been removed, right? Element 3 will be removed. You can do just print list 1. You can do print list 1. So see, element 3. Why 3? Because element 3 is at index number 2. That is why element 3 has been removed. Correct? Then the third one is del keyword, right? The third one is del keyword. So again, list 1, del is a keyword, list 1, and pass the index. Let's say I want to delete the value at third index. Third index is value number 4. Or let's say I want to delete value at fourth index. So del list 1 4. Delete from list 1 value at index number 4. Now over here, guys, pop, remove, these were methods, these were functions. That's why we used parentheses over here. Del is a keyword, it's not a method. Del is a keyword, and that is why we are using square bracket over here to tell the index of the element to be removed. Print list 1, okay. Sorry. Print list 1.
Reading to
Sorry.
ಇದು ನೋಡ್ದ ಎಲಾನ್ ಮಸ್ಕ್ ಇಲ್ಲ ಇದು ಟೇಬಲ್ ಟ್ರಕ್
Someone's unmuted.
ಪರವಾಗಿಲ್ಲ ಅದು ಮಾತ್ರ ಅದನ್ನೇ ಹೇಳ್ಕೊಂಡು ಇವನು.
Okay. Print list 1, 1, 2, 3, 4, fifth. The last element has been removed. Okay. Then we'll do this basic operation on list, the last slide, and we'll take a break of 5 minutes. Okay. Checking membership, checking the length. Now checking membership means, suppose, let us say you need to check if any element is present in the list or not. If any element is present in list or not. So for that, you use the in operator. You use the in operator. Let's say print 4 in list 1. Now let me tell you what I'm trying to do over here. Print 4 in list 1. I'm trying to check.
25
someone is unmuted. Please can you mute yourself?
ಇವರು ನಾಗನಿಗೆ ಕಾಲ್ ಮಾಡಿದ್ರಂತೆ ಯಾರು ಇದು ಅವ್ನು ಡಾಮಿನರ್ ಅವರು ಅವ್ನು ಡಾಮಿನರ್ ಕೊಟ್ಟಿದ್ನಲ್ಲ.
I think I have to tell John.
ಅದು ಇಂಜಿನ್ ಪ್ರಾಬ್ಲಮ್ ಅಂತಲ್ಲ, ಅವ್ರು ಏನೇನೋ ಮಾಡಿ ಏನೇನೋ ಅದು ಇದು ಕಂಟ್ರಿಗಲ್ಸ್ ಎಲ್ಲ ಮಾಡಿ ಏನೋ ಇಂಜಿನೇ ರಿಪ್ಲೇಸ್ ಮಾಡಿದ್ರಂತೆ. ಅದಕ್ಕೆ ರಿಪ್ಲೇಸ್ ಮಾಡಿ ಈಗ ಫರ್ಬಿಸ್ಟ್ ಅಂತ ಇಟ್ಟಿದಾರಂತೆ. ರಿಫರ್ಬಿಶನ್ ನಿಲ್ಸಿದ್ವಿ. ಅಲ್ಲಿ ರೀಸನ್ ಹಾಕಿರುತ್ತಲ್ಲ ಏನಕ್ಕೆ ಏನು ಪ್ರಾಬ್ಲಮ್ ಐತೆ ಬ್ರೇಕ್ ಬರಬೇಕು. ಸೊ ಇಂಜಿನ್ ಯಾರು ಬೈ ಮಾಡ್ತಿಲ್ಲ ಅದನ್ನ. ಸೊ ನಿಮಗೆ ಗೊತ್ತು ನಿಮ್ಮ ಗಾಡಿ ಬಗ್ಗೆ, ನೋಡಿ ನೀವೇ ಬೈ ಮಾಡೋದಿದ್ರೆ ಮಾಡಿ ಅಂತ ಹೇಳುವಂತ ಅವನು 1.5 ಲಕ್ಷ ಅಂತ 9,000 ಅಂತ.
Okay, now let us check what is being done over here. Let us check what is being done over here, right? Print 4 in list 1. What I'm checking over here is 4 present in the list 1, right? So in this list is element 4 present. Execute it, you will get true. You are getting true, right? Why are you getting true? Because 4 is present. Now let us check that if 10 is present in list 1. Let us check if 10 is present in list 1. It will return us false. Why? Because element 10, if you check the list over here, 10 is not present inside the list. It's only 1, 2, 3, 4, 5. So 10 is not present, because of which you are getting false. So in operator is a membership operator which checks for any condition. Is this element present in list? Is this element present in tuple? And so on and so forth, right? And then finally, before we take a break, this is the len function. The len function. Len list 1, it's going to return you the total number of elements inside a list. It's going to return you the total number of elements inside a list. So 1, 2, 3, 4, 5, there are 5 elements, it returns you 5. Correct? Fine, guys. Any questions, any doubts, you can unmute yourself. We'll take a break of 5 minutes, then we'll begin. Okay? So within the time, if you have any questions, any doubts, please unmute and ask. Even the offline students, you can ask any questions or doubts. You can basically go ahead. Right? Thank you. Okay, so let's begin with the remaining part. Now, we'll see some of the list manipulation techniques, right? List manipulation techniques. I mean, reverse, sort, copying, list constructor, then counting the occurrences. Okay, so to reverse the order of the list, we have a function called reverse, right? We have a function called reverse. We have a method called reverse. I'll tell you, I'm calling functions and methods, but I'll tell you the difference between a function and method in the subsequent sessions. Okay, so now to reverse a list, when I say reverse, basically this list is 1, 2, 3, and reverse of this list is 3, 2, 1. So, yeah, reversing the elements of the list. Reversing the elements of the list can be done using a function called reverse. Okay, so list 1 is 1, 2, 3, 4, 5. Let's print list 1 dot reverse. So it's basically reverse is a function that helps us. Okay, list 1 dot reverse, it's not taken. So it will directly print, I guess. Print required. List 1 dot reverse. List 1. Okay. Yeah. So it's directly going to reverse the current order of the list. Okay. Now, the second method is sorting. Sorting basically means to sort a list in ascending order. Suppose I have 1, 3, 2. Now, when I sort this list in ascending order, it will be 1, 2, 3. So basically, it's sorting the elements inside a list in ascending order. Correct? So, why are they talking about count over here? Let's show the count. I think a copy paste mistake. Okay, fine. So, list 1, to sort a list, we have a method, we have a function called sorted. Sorted followed by, the syntax is sorted followed by the list that you need to sort. Okay, and let me create some different lists over here, right? 1, 3, 2, 5, and 4, right? So 1, 3, 2, 5, 4. This is not a sorted list. Sorted list 1, I expect the list to be sorted in, the elements to be sorted in ascending order. Correct? Sorted list 1. Okay. Now, the next is copying. Copying basically is create a copy of the list. Create a copy of the list, right? Create a copy of the list. So basically, if you see, list1 is equal to, let's say list1 is equal to 1 2 3 4 5. Let me create a variable lst1. Now I'm given it the name lst1, right? Both the variable names are different. Or let's say list underscore 1, I name it, okay, is equal to list1 dot copy. List1 dot copy. Print list underscore 1. Print list underscore 1. See, so basically a copy of this list has been made and the copy has been assigned. Copy means the same list, right? The same list, copy of that has been made and assigned to this variable list underscore 1. List underscore 1. Okay. Generally, you make copy of any data type in Python if at all you basically don't want the original to be changed. Right here in the copy, if you make any changes, if you make modify, if you modify, if you remove the element, if anything of that sort, it won't affect the original one. Okay. List constructor. List constructor is nothing but how to create a list. How to create a list using a function, right? So we already know that list can be created using a square bracket. But suppose, let us say that I have a tuple tup tuple 1, let's say, right? And I create it as a 1 comma 2 comma 3 comma 4 comma 5. Okay, this is a tuple 1. Let's see the type of tuple 1. Type tuple 1. Print the type of tuple 1. It will show you a tuple, right? But now, if suppose I want to create a list out of the elements of tuple 1, what I do is, let us call list underscore 1 is equal to, I write a list function and inside that I will pass this tuple 1, right? So what I'm trying to do is list underscore 1 is a list of the elements from tuple 1. Okay, let us try and get the type of list 1. So see, we are able to convert a tuple, the elements of, we are able to take the elements of the tuple. Now guys, this tuple is not going to get converted, right? Tuple is not going to get converted. We will take the elements of the tuple and create a list out of them, right? So create a list out of the elements of the tuple. That is what we have done over here, right? And the data type is list. So this is a data type conversion which is possible. We have converted elements from a tuple into elements of a list, right? So data type conversion that we saw over here yesterday. Yeah, this is one of the data type conversion, right? You can convert you can convert a tuple, elements of a tuple into a list. Allowable, right? And then counting the occurrences. It's the same, right? Just like we have done in the string. In string, we count the number of, sorry. In string, we count the occurrence of substring, and in list, we can count how many times an element is present in a string. Sorry, in a list. One, two, two, let's say, then three, sorry, three, four, five, comma five, comma five, comma five, comma five, five. Okay. Now print list one dot count. This is going to count, right? What is going to count? How many times an element is appearing. The frequency of element in a list. Okay. So list one dot count one. So see, it's appearing once. Element one is appearing once. Let's see element two, right? In the parentheses, you need to pass the element that for which you need to check the count for. Okay. Element 3, it's appearing two times. Element 4, it's appearing one time. Element 5, it should return us 5. Element 5, okay, it's returning 6. So yeah, element 5 is returning 6 times, right? So the count method returns you how many times, or it returns you frequency of the element that you need to check. Any doubts, any questions, anyone? Okay, perfect. Now, let's have a look at the slicing and indexing in a list. So it's basically exactly the same, like what we have seen in strings yesterday, right? I'll still make it a bit clear, right? Now, whenever I create a list, let us say I'm creating a list, right? Let us say I'm creating a list. LST is equal to 10, 20, 30, 40, 50. Let us say, correct? I've created this list. Now, whenever I create a list, the elements by default in Python, the elements will be stored inside a list, will be stored by their index values. So element 10, the first element will have index value 0. Second element will have index value 1. Third element will have index value 2. Fourth element will have index value 3. Fifth element will have index value 4, and so on and so forth, right? Yeah. Oh, sorry, yeah, 4. 4. And the same way, we have the concept of negative indexing as well, right? The same way we have the concept of negative indexing as well. So the first element from reverse, or the last element, will have an index value of -1. Second last element, -2. Third last element, -3. The next element, -4. The next element, -5. Correct? Now, if I want to index a single element or multiple element in a list, I'm going to use the concept that we have used yesterday itself, right? So LST 1, it's going to return me the element at first index, that is 20. LST square bracket -2, it's going to return me index at -2, -2, that is 40. If I want to slice, or if I want to multiple elements, LST 0 till 3. Can anyone tell me what all what all this is going to return me, what all elements it will return?
10,
10,
20, 30.
20, 30. Perfect. The last element is ignored in Python by default. When you index and slice, last element is ignored by default. So 10, 20, 30. Okay, so let us do one thing. Let us create this list and let us see, right? There are some cases that I need to tell you, right? So list 1, 5, will create a big list, 7, 8, 9, 10, 9 and 10, right? Let's do one thing, we'll add 0 after all so that it's not confusing. So our list consists of 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now, if I write list 1, 0, it returns me the first element, that is 10. Okay, execute it. Perfect. Let me write a negative index, -3, let's say. So print list 1 -3, -1, -2, -3. So it should return me 80. It should return me 80. Now, let's say that I am pulling out elements from beginning from 0 till 7. Beginning from 0 till 7, or let's say beginning from 1 till 7. Okay. So index number 1, index number 2, 3, 4, 5, 6. By default, 7 will be ignored. Index number 7 will be ignored, right? So it should return me 20, 30, 40, 50, 60, 70. Execute it. 20, 30, 40, 50, 60, 70. Now, I want an answer from you. So see, here we are providing the starting index. Here we are providing the ending index. Okay, we are providing starting index, we are providing ending index, right? Now, let's say that I provide the starting index as 3 and I don't provide any ending index. Can anyone tell me what has happened over here? Ending index. What it will do, if I don't pass any ending index over here, by default, it will begin from position 3, it will begin from location 3, index 3, and by default, if I don't pass the ending index from 40, it will display till the last entire list. So if I don't pass ending index while slicing, it is by default going to show me until the last. By default, the ending index will be the end of the list, as simple as that. Now, let us say, on other hand, let us say I don't provide the starting index. At ending index, let's say I'm providing 8. Now, can anyone tell me what do we expect over here? Correct. When I don't provide the starting index, by default, Python thinks that it has to begin with index 0 till index number 7. Till index number 7. 8 will be ignored, right? So 0, 1, 2, 3, 4, 5, 6, 7. And now, next question, what if I don't provide both? Hmm? No, what if I don't provide both? If I don't provide both, it is going to by default, exactly from 0 to 9. It's going to by default show me the entire list. It's going to show me the entire list. If you don't provide the start index and the end index. It will show you the entire list. Okay. Now you can give the step size as well, beginning from 1 till 8th index and a step size of 2, right? So it will begin with this first. Step size of 2 means every second element. Step size of 2 means every second element. So it will begin with index 1. This is the first element, second element. So 30 will be skipped. So 20, then 40, 50 will be skipped, 60, 70 will be skipped, 80. Okay. Execute this. So see, 20, 40, 60, 80, a step size of 2. If you want, you can provide a step size of 3, 0 to 9 in a step of 3. Execute. See, 10, 40, 70. Correct? In a step of 3. Step of 3 means every third element. So 10, 20, 30 skip, 40, 50, 60 skip, 70. Right? And then 80, 90 skip, 100 is out of range. Right? We are pulling till the 9th index. Okay. And one more thing I would like to show you is, can you tell me what is happening over here? Yeah, any question? When I pass a negative step size, I'm not passing the starting index, I'm not passing the ending index, but the step size I'm passing is negative. Here I was passing positive step size. Now I'm passing negative step size. Can anyone tell me what it's doing?
Sir, I guess it is from last to first, like
Exactly.
coming backwards.
It is the same thing that we have done using dot reverse. Right? Here we reverse the order with a double colon minus 1, we reverse the order of the list. So there are two ways to reverse the order of the list. Either use the reverse function directly, and if you don't remember that function, use this logic. Use this logic. Reverse it using a double square bracket, double colon minus 1. This is a simpler logic than remembering dot reverse. List 1, double colon, don't give any start, don't give any end, and give the step size of minus 1. By default, it's going to reverse the list. Are we clear on this, guys? Any questions, any doubts, any issues? Yeah.
Yes, sir. Can you go back to that example
Mm-hmm.
where you were showing? I want
Mm-hmm.
to check about this. This one 0:9:3. The second last example. How do you get that?
Okay, see, 0, comma 0 colon 9 colon 3, right?
Yeah.
So see,
Yes.
first of all, let's see where this 9th index is. Okay, so
Yeah.
9th index is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically,
Yes.
9th index is the last one, right?
Yes. Yes.
Now, in Python, when I write from 0 to 9, the 9th index by default will be ignored.
Okay. The last one will be ignored. Yeah.
Yes, the last one will be ignored. So
Yes.
conventionally, it is going to show me the numbers from 10 to 90 with a step size of 3. Okay.
Okay.
Now step size of 3, let's begin with 0.
Yeah.
What is the element at 0th index? 10.
10. 10.
Now let's take 3 jumps. 1,
Yeah.
2, 3.
Yeah.
Next
40.
element is 40.
Right.
Let's take 3 jumps. 1, 2, 3. Next element is 70.
Yes. 70.
Let's take 3 jumps. 1, 2. Are we going to go over here third?
Oh no, it will not count.
Definitely not, right?
Yeah,
Why?
yeah,
Because
got.
this is where it's ending.
Yes.
So after 70, we will not have any output. 10, 40,
Yeah,
70 is correct?
yeah, got it.
Okay, perfect. Yeah, start is optional, stop is required, step is optional. In fact, all of them are optional, right? You can provide start, stop, you can provide start, can or cannot, can or cannot provide stop, can or cannot provide step. It's perfectly fine. If you don't provide start, by default, it will consider 0th index. If you don't provide stop, by default, it will consider last index, right? At last index, when I say last index, it's going to display the last one as well, right? And when you don't provide step, by default, the step size will be 1. Correct? So we have seen all this. Yeah. Okay. One thing that is left is slicing a nested loop. Slicing a nested loop, right? So now the concept is very simple. So now let's say that this is one list, this is the second list, and this is the third list. Okay, the nested list concept. Okay, first list, second list, third list. Now, can anyone tell me if I write print 0, can anyone tell me what would be the output of print 0? 10, 20, 30 all together. So the output of print 0 will be the first element of list 1. Sorry, list 1. First element of list 1. And over here, see guys, first element of this list is 10. But the first element of this nested list is
10,
one
20,
list
30.
itself,
Yeah.
right? It's a list itself, right? So it's going to return me 10, 20, 30. Now, if I want to get an element inside this list, I mean, I want to get into this list and then into this list and get the first element of the first list. First element of the first list. This is the first list. I want to get the first element of this list, right? How do I do it? List 1 followed by square bracket. This returns me 10, 20, 30. Again, one square bracket followed with 0. Execute, you get the first element of your first list. If you want second element of first list. If you want the second element of second list, sorry, if you want second element of second list, list 1, 1. This returns you second list, and this returns you second element of that second list, right? Second element of second list is 50. It's returned as 50, right? So this is how you can index a nested list as well. This is how you can index a nested list as well. We clear with that? The concept of nested list. List comprehensions I will take once we cover the loop section, right? Because list comprehension consists of loop, right? There's a for loop that runs into list comprehension, right? So once we are done on the day we'll do this loops and functions, I will cover the topic of list comprehension. Loops and function. This is going to be the fourth session, right? The fourth lecture. On this day, I will cover the list comprehensions. Correct? Today, Next we go on the tuples, right? Next we go on to the tuples. Now tuples are very much similar to the list, guys. Tuples are very much similar to the list, just that they are immutable. They are they cannot be changed, right? They cannot be changed, they cannot be modified, right? And just there are some different methods or different functions that are used with tuples, okay, because they cannot be modified. So you cannot use these methods, right? I mean that we have seen: append, addition of element, extend, extending of the list, insert, right? These cannot be used. Remove, delete, these cannot be used with tuples, correct? These cannot be used with tuples. Yeah, membership and length, they can be used, but these cannot be used with tuples. Okay, so there are different set of methods that come with tuples. Now, to create a tuple, let's create our first tuple. Just a second. Yeah. Let's create our first tuple. Tuple is created using a parentheses. Contrary to list where we create it using a square bracket, tuple is created using parentheses, right? Let's call an empty tuple, empty. Empty is equal to parentheses, print type of empty, and then tuple 1 print type of tuple 1. Both of them are going to return the data type as tuple. Execute this. See, the data type is tuple for both of them. So you can create an empty tuple using a parentheses with no values, and then you can create a tuple with some values in it, comma separated values in it, right? With comma separated values in it, right? You can create a tuple as well. Just like list, right? 1 2 3 4 5 6. Again, there is no restrictions to the data type, guys. There is no restrictions to the data types. A list can consist of consist of all numbers, all strings, all float, or can consist of a mix of every one of them, right? It can consist of tuples as well, right? Nested tuples as well. Even the nested tuples, exactly like nested list, works fine. Now, suppose, yeah, attempting to change the tuple, right? Attempting to change the tuple. Okay, one thing I would like to tell you, yeah, in the list, right? In the list, there is one thing that I want to tell you, right? I think I might. Go, yeah, just yeah. Now, if I want to change a list, I'll talk about list first, and then I will move on to tuple, right? If I attempt to change a list, if I attempt to change a list, see, right? Let's say that instead of 40, I want 400. Assume instead of 40, I want 400. How do we make this modification in a list? List 1 is equal to list 1. Sorry. list 1, 40 is at what index? 40 is at 0, 1, 2, 3, right? List 1, index 3 is equal to 400. What I'm doing over here, to the third index of list 1, that is 40, this is the third index of list 1, to the third index of list 1, I'm assigning a value of 40. See, I'm using the assignment operator over here, right? To the third index of list 1, I'm assigning a value of 400. Now let's print the list 1. Let's print the list 1. See, 40 has been replaced by 400, right? This is how I can use the index values to replace the elements in a list. Now, why I told you this is I wanted to try to do the same thing with a tuple. See over here, right? I did it. I mean, I was able to change the value 40 to 400. It is allowed. Mutability. Mutability of a list. Let us try with a tuple. Let's say in tuple 1, I want to replace 4 with 40. So tuple 1. Now, do you think, guys, will it be possible? Do you think will it be possible? Not possible? Print tuple 1. Tuple object does not support item assignment. Error, right? So basically, what you did in the list is not possible with tuple. It's not possible with tuple. You cannot change a tuple. You cannot change a tuple. Okay? Now, let's try tuple 1 is equal to this. Tuple 1 dot append 7. Let's try this. Tuple does not support attribute as append. Right? So modification is not possible directly. Right? Modification is not possible directly. But yes, if you want to add some elements in the tuple, you can use plus. But again, let me show you something, right? So tuple 1 is equal to 1, 2, 3, 4, 5, 6. Tuple 2 is equal to tuple 1 plus 7, 8. Now let's print tuple 2. Let's print tuple 1. Let's print tuple 1 and let's print tuple 2. Tuple 1 is not modified. If you see, tuple 1 is not modified. It is as it is. Tuple 2 is the new tuple that is created. See over here, we are doing modifications. We are adding elements to tuple 1. But after addition of the elements, we will have to store it in a new variable. You cannot modify the existing tuple. No. If you make amendments, you will have to store it as a new variable. You will have to create a new tuple for that. You cannot modify the original tuple. Here we have already seen. Correct? So now we have added 2 elements using plus, right? Dot append will not work. Using plus, we have added 2 elements. But then it needs to be stored as a different tuples. Original will, in any case, remain as it is. There is no rule that can change a tuple in Python. By default, tuple remains as it is. Clear, guys? Basic operations on tuples, right? So similarities, tuples and lists share some basic operations, some basic similar operations like indexing and slicing, exactly the same way that we have done in list, right? Exactly the same way that we have done in list, right? Indexing and slicing. Do we have indexing and slicing? Concatenation, indexing and slicing. Yes, we have, right? Yeah, fine. So indexing, slicing, we'll talk later, right? Because we have it. Similarities, tuples list share some basic operations. Indexing and slicing is same in both. It support a length function as well, right? So length in list gave us the total number of elements. Length in tuples is going to give us the same thing, total number of elements. So length will work with both list and tuples. Differences, tuples are immutable, so operations like addition, removal, modification are not applicable, right? The original tuple will never change whatsoever case it may be. Okay. Now, concatenation, concatenation, two tuples can be concatenated, but again, you will have to store it as a different tuple, right? Into a different variable. Let's say, let's create two tuples, right? Tuple one, we'll create a smaller one. 1, 2, 3. Tuple 2, let's create strings. A, B, C. Concatenating two tuples exactly as we have done concatenating string 1 plus string 2. Concatenating tuples, let's say concat underscore tuple is equal to tuple 1 plus tuple 2. Print concatenated tuple. See, so both the tuples have concatenated into a single one, right? But these two remain unmodified. You cannot modify these two for sure. Repetition, repetition. You can very well repeat the tuple, like tuple 1 is equal to 1, 2, 3. Let's say repeated tuple, a repeat tuple is equal to tuple 1 into 3. Print rep tuple. See, 1, 2, 3, 1, 2, 3, 1, 2, 3. The elements in the tuple are repeating 3 times into 3. 3 times they are repeating, right? So 1, 2, 3, 1, 2, 3, 1, 2, 3. They are repeating 3 times in a new tuple called repeated tuple, right? So you can do the same thing, like instead of 3, try for 6. It will be repeated 6 times. So such arithmetic operations are actually possible, right? Such arithmetic operation, even string it's possible. str1 is equal to, let's say, a str1 into 3. It will be a. Oh, sorry. str1 is equal to a Just a moment. It's taking the, oh sorry, this is SRT arrow. My mistake. STR, right? So see, it will be AAA, triple A, right? So same thing, multiplied by 6, multiplied by 6, multiplied by 3. Actually, this does not make any sense. A into 3, this does not make any sense. Tuple into 6 does not make any sense. But fine, right? As no modifications is allowed, at least some operations can be done. Then iteration, tuple can be iterated upon for loops, right? Just like list, tuple can be iterated upon by loop. Okay, we'll talk about this in loops. Tuple packing and unpacking, right? So tuple packing and unpacking is basically, see, now if you have tuple one is 1 2 3. Tuple unpacking is basically multiple assignment that we have taught yesterday. So A comma B comma C is equal to tuple 1. Print A, print A, print B, and print C. Can you tell me what has happened over here? Can anyone tell me what has happened over here? Exactly. If you see, variable A has been assigned the first value, 1. Variable B has been assigned the second value, 2. Variable C has been assigned the third value, 3. Right? So it's the same as multiple assignment. It's the same as multiple assignment, right? And this is what unpacking of a tuple basically means, right? Now you can check the length, you can check the membership exactly the same way that we have done in list, correct? So tuple 1 is this, print length of tuple 1, print length of tuple 1, it returns you the total number of elements in the tuple, exactly like it did in the list. Total number of elements in the list, here it returns total number of elements in the tuple. So length function is the same. You can even check using membership operator like we have done in the list. Print 4 in tuple 1. Print 4 in tuple 1. If 4 is present, it returns true. Print 10 in tuple 1. 10 is not present, it returns me false. Right? So the membership operator works exactly same like we have in the list. Then indexing and slicing of tuples. You will see at that. Indexing. Okay, so fine. Indexing and slicing of the tuples, right? Okay. So tuple 1 is, let us create, okay, I'll do nothing. I'll just copy paste this entire thing. I'll just copy paste this entire thing because it's literally the same. Nothing is different. just replace this with a parentheses. That's it. So now let us call it tuple 1. Tuple 1, right? And wherever you have list 1, replace all with tuple 1. Tuple 1, tuple 1. Execute, the same thing you get. Here in list, you got the values, you got the answers as list. In tuples, you will get the answers as tuples. As simple as that. That's the only difference. Right? Remaining everything is exactly the same. 0th element 10, minus third element 80, 1 to 7, 20, 30, 40, 50, 60, 70, 3 till last, from the third till the last. Zero, we don't pass anything in the start position. It by default it takes from the start, right? We don't pass in the start and end position. It displays everything. The step size concept is the same, and the reversing concept is also the same. Okay, reversing concept is also the same. Right, guys? So the indexing and slicing in the tuple is exactly the same as we have in list. Right? Slicing and indexing in tuples, immutability of tuples and implications. Tuples are immutable, meaning their elements cannot be changed, added, or removed after creation. Implications, data integrity. Once a tuple is created, its element remain constant. Its elements remain constant, right? You cannot change the original tuple at all, ensuring data integrity. Hashability, tuples are hashable, meaning you can index them, right? You can index them. Performance, immutable structures may have performance benefits in certain scenarios. Like if you don't want to change your data, right? You use a tuple. That's it. So by mistake in your code, if you attempt changing a tuple, it is directly going to return you an error. Thread safety, immutability contributes to thread safety as data cannot be altered unexpectedly. I mean, thread safety and immutability, right? Both of them are nearly same. Thread safety and data integrity. Common operations on both lists and tuple. So we have seen membership testing, that is in, right? The in keyword. It works for both for list as well as tuples. Concatenation, two lists can be concatenated, two tuples can be concatenated exactly in the same way. So list 1 plus list 2 works. Tuple 1 plus tuple 2 works. Okay. Repetition, right? Into 3, into 2, the same thing works for list, the same thing works for tuple. And then finally, conversion between lists and tuples. You can convert a tuple to a list, and if at all you want to convert a list to a tuple, data type conversion we have already seen, right? Have we done that? Yeah. So see. Now I'll just reverse the code over here, right? List 1. list 1 is 1, 2, 3, 4, 5 with square brackets, and tuple 1 print type list 1, and tuple 1 is just like we did for a list, we have a function called tuple, right? So for type conversion, we have a function called tuple, and I will pass list in it, list 1 in it. Let's check the data type. This should be a list, and when I pass this list into a tuple, it will take all the elements from the list and create a tuple out of them. So data type of a tuple. Let's check. See, data type of a list is list, tuple is tuple. So you can convert the data type, you can convert a list to a tuple. I mean, take the elements from a list and convert it to tuple. As simple as that. So even type conversion is possible between list and tuples. You can check the hands-on database. Any questions, any doubts, any issues with the topic in these 2 days, guys, over this weekend? If you have, you can very well ask. Online, offline, guys, any doubts? No? Online, guys, any questions you have, any doubts, any issues?
No, sir.
Okay, perfect, that makes sense. Mudassir, you have raised the hand, but I'm not specifically sure. I mean, you, if at all you want, not sure how I can take you into this stage, but yeah, if at all you want, if you cannot unmute yourself, you can ask your doubt in the chat section. Because I'm not able to take anyone on stage. That's all right. I'm not the host actually. Okay. Fine, guys. Hope you had a nice time learning, nice session, and you were able to learn something new. Thanks for listening patiently. We'll meet in the next session on next Saturday. Thanks for joining. Have a happy Sunday, guys. Thank you.
Hello.
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 Hi, yeah, I'm able to hear you.
Yeah, sir. Actually, I wanted to ask, like, we'll get notes of these 2 classes, right?
Yeah. The PPT will be made available to you, right? My material comes directly from the PPT, right?
Okay.
It will be
Okay.
made available to you. Don't
Yeah.
worry about it. Okay?
Thank you.
Sure.